Hello everyone, my name is Noah Stanley and today I thought I would talk to you all about how guitars work. Instruments have always been subjects of interest to me. I've always been curious as to how they work and I've always loved how many of them sound. Um, my favorite of those obviously being the guitar. And while I'm not the most experienced player out there, I do know how to play it. But I've never asked how it works, never wondered why or how it is able to produce the sound it is able to make. Um, so today I wanted to explore how the acoustic guitar works, how it creates its sound, and how the electric guitar works. To start off with a brief history, the earliest instruments that appeared resembling what a modern day guitar would look like showed up around the 12th century in Spain. And these didn't exactly look like the guitars you see in these pictures here. They looked a bit different. And the first modern guitar didn't show up until around the 18th century. It was created by a Spaniard by the name of Antonio Torres Jurado, and he created he created this picture up in the top right by he created two prototype guitars, and he took the best aspects of both and he combined them into one instrument. And some of the elements of those two instruments that he combined were obviously he increased the size of the guitar. He reinforced it with stronger wooden bits of metal because in increasing that size and the size of the strings, the tension these strings created would cause the entire instrument to collapse on itself. So on top of that, he also took the strings which were made of gut or animal guts and turned them and changed the material to steel or nylon strings. And the electric guitar didn't make an appearance until way later, around the 1930s, when two guys by the names of Les Paul and Leo Fender created the first prototypes of electric guitars. And the first prototypes were not perfect. They were almost direct imitations of what an acoustic guitar was, which was hollow, the big hole in the middle, and that created problems because an electric guitar takes the sound that the strings make and turns them into electrical signals. But with that hollow center, there was too much feedback, too much vibrations, and the sound was very coarse. It was rough. It was not very clear. So they changed it to a hard body with no hole. No, it wasn't hollow. It was completely solid throughout the middle, and the models that they created are still being sold to this day. Then the two pictures below here. And they're also very popular brands, both of them. They're very popular among some of the best musicians in the world. Start with an acoustic guitar and its parts. At the top you have the head, which is usually a piece of wood, and its only real use is where the tuning pegs are, which those are the dials that allow you to change the tension of the strings to get a higher or lower pitch out of them. Next is a neck, which is this long bit here, and that allows the strings to be longer, so you can get a certain sound out of them. The neck contains the fretboard, which is which contains frets, which is these little metal protrusions from the neck, and when you press your finger down behind them, it allows you to play a certain note that each string produces a different note, different pitch. Next, you have the body, which contains the soundboard, the sound hole, and the bridge. So the soundboard is what takes the vibrations and the sounds that the strings make and it amplifies them. Because the strings, since they move a lot and they're very small, they don't disrupt the air that much. And so they create a very low pitched sound. And the soundboard is able to amplify that sound and produce the sound that we can all hear. And the sound hole and the hollowness of that guitar allows the soundboard to really move and to really like oscillate, so you can get a very loud and like a louder sound and a very clear sound. And then obviously there's the strings, which are the source of the sound that the guitar makes. And the strings are all different sizes. You start the lowest pitch will be the thickest string, and you go all the way around to the highest pitch will be the thinnest string. And there's a lot of different types of guitars. This one is a 6 string in the picture, but there's others that are 12 strings. So, and the 12 string creates a whole different sound than what this 6 string would make. As for the electric guitar, it essentially works the same way. You got many of the same parts: the head, neck, fretboard, fret. The only major difference is that the body is not hollow. There is no large sound hole underneath the strings, and instead is replaced with these pickups, which are those 3 objects you see right underneath the strings. And what those pickups do is they take those vibrations that the strings make, and they change those vibrations into electrical signals that can then be sent to an amplifier to create sound. So there's no real need to amplify the strings, the sound that the strings make through the air with a soundboard and a sound hole, because those vibrations, those oscillations that the strings make are picked up by the pickups. So that whole process is not needed. And obviously you have to plug this guitar in to an amplifier. It can't work on its own. If you use it on its own, it creates a very low sound that no one's really gonna like. But there's a lot of different variables that can affect how a guitar sounds, like the strings for one, the mass of the strings. So like I said, the thicker the string, the lower the pitch it's gonna make. And so that's why the thickest strings are on the one side, and it goes thick, it goes low to high. As you can see in this picture, the lowest string on the left, or the thickest string on the left, the thinnest string on the right. The length of the strings also matter too. You can look at the strings instruments like the violin, the bass. You can look at a ukulele too if you wanted to. So as length increases, pitch decreases. The pitch gets lower. So you can see a ukulele, very small instrument with the strings aren't as long as you can see on an acoustic guitar, and it creates a very high pitched sound compared to what this makes. You can look at a violin and a bass. Size difference changes. The strings are different lengths, and that's what affects that pitch a lot. And also the tension of the strings. As you can see, the entire point of the tuning pegs on the head is to change the tension of the strings. So you can see these strings are wrapped around the tuning pegs, and when they get tighter, they create a higher pitch, a higher frequency. And the same goes for when you loosen the strings. They create a lower pitch, a lower frequency. You can kind of test it with a rubber band if you wanted to. Increase the tension, lower the tension. You can do this at home. And obviously, the size of the entire guitar changes too. The body dimensions are huge when it comes to the overall guitar sound. And on an electric guitar, the pickups play a huge role in the sound that it creates. You can change the type of the pickups, the configuration of them. And also the number of pickups changes too. I've seen a lot of electric guitars with 2 pickups, 3 pickups, and I don't have a personal preference between the two. I think they both sound great. And even the height of the pickups, how the distance between them and the strings can also play a huge role in how the guitar sounds. On an electric guitar, obviously, you can tell it has a lot more variety when it comes to sound compared to an acoustic, and that's mainly because the amplifier can change all the electrical signals, and it can distort it can clear, but that doesn't come down to how the guitar works. It comes down to the amplifier, so we're not going to jump into that. But in conclusion, so all these different parts of the guitar, the head, the neck, the frets, the soundboard, the bridge, the hole, they all work to amplify the sound, the vibrations that the strings make. So alone, the strings would make very little noise, very hard to hear noise, and honestly, there wouldn't be much variety in the sound that the strings make. So all these parts go into giving that variety, giving that versatility, and giving that signature sound that we all know and love. On an acoustic guitar, the sound is amplified through the sound bridge, which will be this top of the guitar, the face, and the sound hole, which that hollowness that allows the soundboard to really vibrate and create that sound. On an electric guitar, it is amplified by the pickups. So there's no sound hole, no hollow body, completely solid, and those pickups pick up all the vibrations that these strings give off, and transforms them into electrical signals for an amplifier to play them back. And through all this whole process is what gives that signature sound of a guitar that we all know and love. It allows for the guitar to be such a versatile instrument that bands all over the world will use. See, you can look at this left picture with the whole rock band, all these crazy lights, these crazy riffs going on, and the same instrument can be used in the mountains in tranquility in a completely different way. So that is how a guitar works. Thank you.